Hi YouTube, Tim Eckert here. In this video, we're going to write the recursive definition for arithmetic sequences and find the fourth and fifth terms. So in question 1, again, it says write the recursive definition for the arithmetic sequence, then use the recursive definition to find the fourth and the fifth terms. We kind of want to see what we do want to see what the common difference between terms is. So if I go from 4 to 7, I add 3 here. If I go from 7 to 10, again, I add 3. So my common difference is 3. So I can start by writing my recursive definition as a sub n, the nth term, equals a sub n minus 1, which is the term before it, plus 3. We also want to include the first term here in our recursive definition so we can tell what terms are in the sequence. So we're going to write a sub 1 equals 4. So this is my recursive definition here. Now I want to find the fourth and fifth terms. So I'm going to say a sub 4, which is going to be the fourth term, equals a sub 3, the third term, plus 3. Okay, so the third term, the value is 10. So it's going to equal 10 plus 3. So that equals 13. Fourth term equals 13. Now we can find the fifth term. A sub 5 equals a sub 4 plus 3. A sub 4 is 13, so 13 plus 3. So that equals 16. So the fourth term is 13. The fifth term is 16. All right, let's try some more. Write the recursive definition for the next arithmetic sequence, then use the recursive definition to find the fourth and fifth terms. Okay, so we want to look at our common difference here when we go between terms. I didn't draw that well. All right, so we add 4 from going from negative 4 to 0, and we add 4 going from 0 to 4. So we'll say a sub n, the nth term, equals the term before it, a sub n minus 1, plus 4. And our first term is negative 4. So a sub 1 equals negative 4. So we got our recursive definition here. Now let's find the fourth term. So we're going to say a sub 4 equals a sub 3 plus 4. A sub 3 is 4, so this equals 4 plus 4, so that equals 8. Okay, a sub 5 equals the fourth term plus 4. So the fourth term is equal to 8, so 8 plus 4, that equals 12. All right, there we go for the second one. Let's go for the third one. Write the recursive definition for the next arithmetic sequence, then use the recursive definition to find the fourth and fifth term. So a sub n equals a sub n minus 1. Okay, we got to see what our common difference here. So 10 to negative 4, we're adding 6. Okay, negative 4 to 2, we're adding 6 again. So we're going to have plus 6 here. And we want to indicate the first term, a sub 1, that equals negative 10. All right, next up, we want to use the recursive definition to find the fourth and fifth terms. So we'll start with the fourth term. A sub 4 equals a sub 3 plus 6. So a sub 3 is 2, so it equals 2 plus 6, which equals 8. Okay, a sub 5 equals a sub 4 plus 6. A sub 4 is 8, so it equals 8 plus 6, so that equals 14. All right, so 14 is the fifth term, 8 is the fourth term. All right, let's try one more. All right, write the recursive definition for the next arithmetic sequence, then use the recursive definition to find the fourth and fifth terms. So when you go from negative 21 to negative 11, we add 10. When we go from negative 11 to negative 1, we add 10. So we're going to say A, do a better A there. So A sub n equals A sub n minus 1 plus 10. And our first term, A sub 1 equals negative 21. Okay, let's find the fourth term. So A sub 4 equals A sub 3 plus 10. So it equals negative 1 plus 10, which equals positive 9. Okay, so A sub 5 equals A sub 4 plus 10. So it equals A sub 4, which is 9, plus 10. So A sub 5, the fifth term, equals 19. That's all there is to it. Hopefully you found this video helpful. If you did, please like and subscribe.